17 years? That's how long I've been pulling transmissions, cracking open gearboxes, and watching the same preventable failures happen over and over again on vehicles that should have lasted twice as long as they did. And for most of those 17 years, I thought I understood transmission fluid. I thought I knew what worked, what didn't, and why the manufacturers recommended what they recommended. I was wrong. Moment I realized I was wrong happened in Nagoya, Japan in the spring of 2018. I was visiting a transmission rebuild facility, a small immaculate operation that serviced fleet vehicles for a regional logistics company. The lead technician there, a man named Hiroshi who had been rebuilding Toyota and Aisin transmissions for over 30 years, watched me examine a fluid sample from a vehicle with 280,000 kilometers on it. The fluid looked almost new. I told him that. He nodded and said very calmly, "Of course, we use the correct fluid at the correct interval. Why would it look different?" I asked him what fluid they used. He named a specification I had never heard of. I asked where I could get it in the United States. He looked confused, then he said something I have been thinking about ever since. "I don't think they send that one to America. They send you the other one." The other one. That sentence cracked something open for me, because here's what I discovered over the following 2 years of research, factory contacts, and more conversations with Japanese technicians than I can count. The global transmission fluid market is not a single market. It is several markets running in parallel. And the specifications that Japanese manufacturers keep for their own domestic fleets, their own taxi companies, their own high-mileage commercial vehicles, those specifications are not the same ones that end up in the bottles on American shelves with the same brand name printed on the label. Before I get into the 15 specific things you need to know, and number 9 is going to change how you think about every fluid recommendation you have ever received, hit subscribe. Because what I'm covering in this video is the kind of information that takes years of direct factory contact to piece together, and I'm not done. There's more coming. Let's talk about why this gap exists. And let's do it without pretending there's a villain in this story, because there isn't. There's just incentive structure. When a Japanese automaker like Toyota or Honda engineers a transmission fluid specification for the domestic Japanese market, they are engineering for a specific context. Japan has a culture of long vehicle ownership, extremely high standards for vehicle condition at resale, and a service industry built around meticulous, frequent maintenance. The average Japanese taxi runs 500,000 to 600,000 kilometers. Fleet operators demand fluids that perform at the highest level for the longest possible time, and they pay a premium to get them. The domestic Japanese fluid specifications are engineered to meet that demand. When that same manufacturer prepares their North American service products, they are operating in a completely different context. The North American market trends toward longer service intervals, lower service frequency, and a consumer base that is much more sensitive to upfront maintenance costs and much less sensitive to long-term vehicle preservation costs. The fluid that gets exported to North America is not fraudulent. It meets the published specification. But the published specification for North America was written for North American maintenance habits, not for the preservation philosophy that keeps Japanese domestic vehicles running past 400,000 miles. That is the gap, not conspiracy, not malice, just two different products engineered for two different markets with two very different goals. In Japan, they maintain transmissions based on preservation. Every component, every clutch pack, every planetary gear set, every torque converter maintained as if the vehicle will be in service for 30 years. In America, we maintain transmissions based on convenience. The interval that fits into a schedule, the fluid that's easy to find, the service that doesn't cost too much this month. The result is that the same transmission in the same vehicle produces wildly different outcomes depending on which philosophy governs it. That governing philosophy is what this video is actually about. Here are 15 transmission fluid secrets that Japanese manufacturers use domestically, but that almost none of that information reaches American service centers. 1. The domestic Japanese specification is viscosity graded differently than what gets exported. In the US, if you look at Toyota's official recommendation for a Camry or Highlander with a U660E or U760E transmission, you'll see Toyota WS Fluid World Standard. That fluid is a low-viscosity ATF designed to reduce parasitic drag and improve fuel economy on EPA testing cycles. In Japan, the same vehicles used in high-mileage commercial applications, taxis, hire cars, shuttle services, are frequently serviced with a slightly higher viscosity variant that does not appear in any North American Toyota parts catalog. The specific recommendation is a fluid meeting JASO 1A classification with a higher film strength rating than standard WS, approximately 15 to 20% higher shear resistance at operating temperature. This matters because automatic transmissions operate through fluid pressure. The clutch packs engage because fluid pressure forces them together. The shift timing is governed by fluid pressure signals through the valve body. When that fluid shears when it loses viscosity under heat and load, those pressure signals become imprecise. Shifts become soft. Clutch engagement becomes inconsistent. Over time, clutch material transfers to the fluid becomes contaminated, and the contamination accelerates further wear. 2. Japanese domestic service intervals for automatic transmission fluid are 40,000 kilometers, not the lifetime fill or 100,000-mile interval published for North America. This is the one that makes American service writers visibly uncomfortable when I bring it up. Toyota, Honda, Nissan, every major Japanese manufacturer publishes a lifetime fill or extended interval recommendation for their North American market transmissions. Lifetime, as in never change it, or 100,000 miles, or 60,000 miles under normal conditions, which are defined so broadly that almost every driver technically qualifies as normal. In Japan, the domestic service schedule for the same transmissions used in the same vehicles is 40,000 kilometers. That's approximately 25,000 miles. Every 25,000 miles, not a flush, not a cooler line flush. A drain and fill, removing the pan, inspecting the filter, reinstalling with fresh fluid to the correct level and specification. Every 25,000 miles. Here is the mechanism that makes this interval logical. Automatic transmission fluid does not simply lubricate. It is the hydraulic medium that operates every function of the transmission. Every shift, every torque converter lockup, every clutch engagement happens through fluid pressure. That fluid operates at temperatures between 175 and 220 degrees Fahrenheit under normal conditions. At those temperatures, the additive package in the fluid, the friction modifiers, the anti-wear additives, the oxidation inhibitors, begins degrading from the first moment the engine starts. By 30,000 miles, the additive package in most ATF formulations is operating at reduced effectiveness. By 50,000 miles, it is significantly depleted. By 100,000 miles, the American normal interval, it is, in many cases, functionally exhausted. 3. The additive packages in domestic Japanese ATF include anti-shudder friction modifiers at concentrations that are not present in North American export formulations. Torque converter shudder. If you have driven a high-mileage automatic transmission vehicle and felt a vibration or shudder between 40 and 55 miles per hour, felt it almost like driving over a rumble strip, even on smooth pavement, you have experienced torque converter clutch shudder. It is extremely common in North American Toyota, Honda, and Nissan vehicles with over 100,000 miles. In Japan, it is significantly less common on equivalent vehicles at equivalent mileage. The reason is the additive package. Modern automatic transmissions use a lockup clutch inside the torque converter to mechanically connect the engine to the transmission at highway speeds, eliminating the slip loss of the fluid coupling. This clutch is controlled by the transmission control module based on speed, load, and temperature. For the clutch to engage and disengage smoothly, the fluid needs to maintain very specific friction characteristics at the interface between the clutch friction material and the converter cover. Those friction characteristics are maintained by anti-shudder friction modifiers in the ATF. 4. Japanese manufacturers test their domestic ATF specifications against real-world humidity and temperature cycling conditions specific to Japanese climate zones, and those conditions are more demanding than American testing standards. This one is underappreciated. Japan experiences significant humidity, coastal humidity, summer monsoon conditions, temperature swings between seasons that create condensation inside transmission housings. The domestic Japanese ATF specification includes corrosion inhibitors and moisture dispersants at levels specifically engineered for those conditions. North American ATF specifications are tested against ASTM standards developed primarily for American driving conditions, lower average humidity in many major markets, less aggressive temperature cycling in the markets where most vehicles are sold. The result is that the domestic Japanese fluid is, in some specific ways, more robust against moisture-related degradation than its American counterpart. This matters because moisture contamination in ATF is one of the primary accelerants of fluid oxidation. Water and ATF react at operating temperatures to form acids. Those acids attack seals. They attack clutch friction material. They accelerate metal corrosion inside the valve body. In high-humidity American markets, the Southeast, the Gulf Coast, the Pacific Northwest, moisture contamination is a real factor in ATF degradation. The domestic Japanese specification is better equipped to handle it. The North American export specification was not engineered for it specifically. 5. The Japanese domestic service protocol includes a transmission pan magnetic drain plug inspection, a step that is absent from virtually every North American service procedure. Every automatic transmission produces metal particles during normal operation. Gear teeth meshing, clutch packs engaging, bearings rotating, all of it produces microscopic metal debris that enters the fluid. This is normal and expected. The question is where that debris goes. In the domestic Japanese service protocol, the transmission pan drain plug is magnetic. A powerful neodymium magnet captures ferrous metal particles before they can circulate through the valve body and damage precision ground bores. At every service interval, the technician removes this plug, examines the metal debris on the magnet, and assesses it. Fine, powdery gray debris is normal wear. Shiny metallic flakes or chips indicate abnormal wear. Brass or bronze particles indicate clutch pack or bushing wear. This single inspection step provides a direct window into what is happening inside the transmission, information that no scan tool or external symptom can give you. North American service procedures almost universally skip this step, because North American transmission pans often do not come with magnetic drain plugs from the factory, because the step adds time to the service, and because there is no diagnostic code generated by normal metal particle accumulation until the damage is severe enough to cause a mechanical failure. 6. Domestic Japanese ATF sold through Toyota's Genuine Parts Network in Japan carries a specific G designation in its part number that indicates a higher-grade additive package, and this designation does not appear on any North American Toyota parts catalog. When you walk into a Toyota dealer in the United States and ask for Toyota Genuine ATF-WS, you receive a product with part number 289 ATF-WS or equivalent. This is a real Toyota product. It meets the WS specification. It is what is recommended for your vehicle. In Japan, the Toyota Genuine Parts catalog includes ATF-WSG, the G designation indicating a premium additive package with enhanced thermal stability, higher friction modifier concentration, and extended oxidation resistance. This product is not available through North American Toyota parts channels. It is not listed in North American service documentation. It exists, is used routinely in domestic Japanese Toyota service centers, and does not ship to the United States market. 7. Japanese domestic service procedures for CVT transmissions specify a fluid change interval of 25,000 miles, and CVT fluid degradation is the single most common cause of CVT failure in North American Nissan, Subaru, and Honda vehicles. I want to spend time on this one because CVT failures are epidemic in the North American market in a way that they are not in the Japanese domestic market, and the reason is almost entirely fluid-related. Continuously variable transmissions operate on a fundamentally different principle than traditional step-gear automatics. Two variable diameter pulleys connected by a steel push belt or chain transmit power across an infinitely variable ratio. The belt or chain rides on the angled faces of the pulleys, and the contact pressure between the belt and the pulley faces is enormous, many times higher than the contact pressure in a traditional gear mesh. This contact requires fluid with extremely high film strength and extremely precise friction characteristics to prevent belt-to-pulley slippage and micropitting of the pulley faces. CVT fluid is, in this sense, more demanding than any other transmission fluid in common use, and it degrades faster under higher stress than conventional ATF. The domestic Japanese service interval for CVT-equipped vehicles, Nissan's Xtronic CVT, Subaru's Lineartronic CVT, Honda CVT, is 25,000 miles. The North American published interval for the same CVTs is typically 60,000 miles for severe service or listed as a lifetime fill for normal service. 8. The gear oil used in Honda's dual-clutch transmissions, sold in North America as Honda DW1, is a reformulated version of a domestic Japanese specification that includes a different phosphorus-based anti-wear package. Honda's dual-clutch transmissions, specifically the 8 DCT used in later Accord and CR-V applications, have had a rocky reputation in North America. Shuddering, hesitation, premature wear on the wet clutch packs, software updates helped partially, What software updates cannot fix is insufficient wet clutch lubrication from fluid that was not engineered for the friction material Honda used in the domestic version of this transmission. The domestic Japanese 8DCT fluid specification includes a phosphorus antiwear additive at a concentration specifically matched to the clutch friction material that Honda sources from a domestic Japanese supplier. The North American export fluid uses a different phosphorus compound, functionally similar but not identical, at a slightly different concentration. The mismatch between the antiwear additive and the friction material is small. But in a dual-clutch transmission where the wet clutches are engaging at low speed, under high load, hundreds of times per day in city driving, small mismatches compound. If you want a complete service schedule, the exact fluid specifications, change intervals, and procedures that Japanese domestic service centers use for Toyota, Honda, Nissan, Subaru, and Mazda applications, I've put together a detailed reference guide organized by transmission type and model year, with specific part numbers for the closest available North American equivalents and the procedure steps that most American service guides leave out. It's at the link in the description. It took a long time to compile. It is worth having before your next service appointment. 9. Japanese factory technicians never use a transmission flush machine on an automatic transmission with more than 60,000 miles, and the reason why will make you rethink every high-mileage flush you've ever had done. This is the one that generates the most pushback when I talk about it, because the automatic transmission flush is a standard high-profit service item at every American dealership and quick lube chain, and it is, in specific circumstances, actively harmful. Here is the mechanism. An automatic transmission's valve body contains dozens of precision machine bores, typically with clearances measured in tenths of thousandths of an inch. The solenoids that control fluid pressure routing fit into these bores. Over time, in a transmission operating with degraded fluid, a thin deposit layer accumulates in these bores, not enough to cause failure, but enough to partially compensate for the slight where that occurs in the bores themselves over high mileage. The fluid in the transmission at this point, while degraded, is carrying the metal particles and soft deposits in suspension, keeping them mobile, not settled. A flush machine connects to the transmission cooler lines and pumps fresh fluid through the unit at high pressure, displacing essentially all of the old fluid within the transmission. This sounds beneficial. The problem is that the high-pressure flow through the valve body dislodges the soft deposits from the bore surfaces, and those deposits, suspended in the fresh fluid, travel directly into the solenoid bores and cause the solenoids to stick. Additionally, the dramatically different friction characteristics of fresh fluid in a clutch pack that has worn into the friction characteristics of old, depleted fluid can cause immediate shift quality issues. 10. Subaru's domestic Japanese ATF specification for the TZ1 and TZ2 5-speed automatics includes a proprietary friction modifier compound that reduces the characteristic clunk on deceleration, and this compound is not present in the North American export fluid. If you own a Subaru Outback, Legacy, or Forester with a 5-speed automatic and you've experienced that pronounced clunk or bump when coming to a stop, felt it transfer through the driveline as you decelerate to a stop, you know exactly what I'm describing. It is one of the most commonly reported complaints about these transmissions in North American Subaru forums. It is almost universally attributed to transmission personality, or normal operation. In Japan, it is not accepted as normal, and it is not present in Japanese domestic market Subaru vehicles maintained on the correct specification fluid. The domestic Japanese specification for these transmissions includes a friction modifier compound, a long-chain fatty acid derivative, that specifically addresses the transition characteristics of the torque converter clutch at low speed, just above stall speed. When the TCC is in partial engagement, partially locked, partially slipping, this friction modifier maintains stable, smooth engagement rather than allowing the micro-slippage event that creates the clunk. Without it, the clutch engagement oscillates slightly, locks, slips, and each micro-event transmits a small shock through the driveline that you feel as a clunk. 11. Every Japanese domestic market automatic transmission service includes a thermal cycling procedure after the fluid change, a specific drive cycle that brings the transmission to operating temperature, executes specific shift patterns, and allows the transmission control module to complete a fluid adaptation cycle. In North America, a transmission fluid service ends when the pan is reinstalled and the fluid level is verified. You drive away. The transmission adjusts on its own over time. In Japan, the factory-trained technician executes a prescribed post-service drive cycle before returning the vehicle. This cycle, specified in domestic Japanese service documentation, involves a cold start idle of 4 minutes minimum, followed by progressive acceleration through all gears to highway speed, followed by a series of controlled deceleration events, followed by a specific sequence of manual gear selections if the vehicle has a sequential shift mode. The procedure takes approximately 20 minutes and costs nothing, only technician time. In Japan, it is considered non-negotiable. In North America, it is not mentioned in most service documentation. 12. Japanese manufacturers have been using ester-based synthetic ATF in their domestic market high-performance and commercial applications since 2009. While the North American market was still being sold mineral-based or Group III synthetic fluid under the same specification designations. This is a base oil conversation, and it matters enormously. Not all synthetic fluids are the same. The term synthetic in the United States is legally broad enough to include Group III fluids, mineral oil base stocks that have been hydroprocessed to improve their properties, but are not truly synthesized from pure chemical precursors. These Group III fluids are sold as synthetic and meet published ATF specifications. They are not what Japanese manufacturers use in their domestic high-demand applications. Ester-based synthetics, Group V base oils built from the chemical reaction of organic acids and alcohols, have superior thermal stability, superior oxidation resistance, and superior film strength compared to Group III synthetics. They do not shear, they do not oxidize easily, they maintain viscosity over a wider temperature range. And their natural polarity causes them to cling to metal surfaces rather than draining away when the transmission is cold or static, providing immediate protection at startup before fluid pressure builds. The domestic Japanese Toyota and Lexus Genuine ATF used in high-mileage commercial applications, the G specification mentioned earlier, uses a polyol ester base oil. The North American Toyota Genuine AEFWS uses a Group III synthetic base oil. This is not publicly disclosed in the product literature for either product. It is in the technical data sheets available from the Japanese factory parts distribution network. 13. Japanese domestic market transmission fluid containers include a condition indicator additive that causes the fluid to fluoresce under UV light when the additive package is depleted, and this feature is absent from North American export products. This one sounds like something from a laboratory. It is not. It is a practical diagnostic tool used by Japanese service technicians since approximately 2014, present in domestic market Genuine ATF for Toyota, Honda, and Nissan applications. The UV fluorescence indicator is a dye compound, specifically a substituted coumarin derivative, that remains fluorescent under UV light when the antioxidant package in the fluid is intact and active. As the antioxidants are consumed by oxidation during normal operation, the coumarin compound undergoes a chemical change that causes it to lose its fluorescence. A technician with a UV lamp can examine a fluid sample from a running transmission and make an immediate, accurate assessment of the remaining additive life in the fluid, without a laboratory analysis, without expensive equipment. 14. The Japanese domestic market version of Nissan NS3 CVT fluid includes a film-forming additive, a metallic organic compound, that deposits a protective boundary layer on CVT pulley faces under high contact pressure, reducing micropitting by approximately 60% over 100,000 kilometers in controlled testing. Nissan's CVT problems in North America are widely documented. The Xtronic CVT has a reputation for failure between 80,000 and 130,000 miles that has cost Nissan billions in warranty claims, class action settlements, and brand reputation damage. Nissan has issued extended warranty coverage, software updates, and replacement procedures. None of these interventions address the underlying cause. The underlying cause, established through materials analysis of failed CVT units, is micropitting on the contact surfaces of the steel push belt elements and the primary and secondary pulley faces. This micropitting begins early, sometimes as early as 40,000 to 50,000 miles, under the enormous contact pressures generated between the belt elements and the pulley faces. Once micropitting begins, it accelerates because the irregular surface geometry creates stress concentrations at the pit edges that propagate further pitting. The end result is a roughened contact surface that generates belt slippage, vibration, and ultimately belt or pulley failure. The domestic Japanese Nissan NS3 CVT fluid contains an organomolybdenum compound, specifically molybdenum dithiocarbamate, that forms a chemically bonded layer on metal surfaces under pressure. This boundary layer acts as a sacrificial film, absorbing the extreme contact pressure between belt and pulley and preventing direct metal-to-metal contact that causes micropitting. Testing published in the Journal of Japanese Society of Tribologists in 2017 showed a 60% reduction in micropit formation on pulley surfaces over 100,000 kilometers when the organomolybdenum additive was present versus absent. 15. Every Japanese factory transmission engineer I have spoken with, everyone, considers a 100,000-mile or lifetime ATF recommendation to be an engineering statement about the maximum interval before probable failure, not a maintenance recommendation for long vehicle life. I want to be direct about this because it is the single most important thing in this video. When Toyota or Honda or Nissan publishes a lifetime fill or 100,000-mile transmission fluid interval for the North American market, what they are publishing is the interval beyond which they expect to see increased warranty claims, the interval at which the probability of a fluid-related failure begins to rise above their acceptable threshold. They are not publishing the interval at which fluid-related wear is minimized. They are publishing the interval at which fluid-related warranty liability is manageable. An engineer I spoke with at an Aisin facility, the company that manufactures transmissions for Toyota and many other manufacturers, put it this way through a translator: a 100,000-mile interval tells you when we expect problems to start. A 30,000-mile interval tells you when we would change the fluid on a transmission we wanted to last forever. He was not being secretive. He was explaining the obvious gap between engineering a product for durability and engineering a maintenance schedule for a market that prioritizes low perceived maintenance costs. Japanese vehicle owners, and I mean domestic Japanese market owners, do not think of transmission fluid as a consumable they service when the manufacturer tells them to. They think of it as a precision fluid that requires monitoring and renewal at intervals determined by engineering logic, not marketing convenience. They spend $600 over 100,000 miles on transmission maintenance. Americans, on average, spend between $0 and $200 on transmission maintenance, and then $5.00 on a transmission replacement. The transmission in your Toyota, Honda, Nissan, or Subaru is the same transmission that Japanese domestic market owners are running past 400,000 kilometers. It is not a different transmission. It is not a stronger variant. It is the same unit built on the same line to the same specification. The only variable is what goes into it and how often. Maintain it like the Japanese domestic market maintains it, or repair it like the North American market repairs it. That choice is entirely yours, and now you have enough information to make it. Drop a comment right now and tell me what transmission you're running, what mileage you're at, and which of these 15 things you're implementing first. I read every comment. And coming up next, the engine oil specification that Japanese manufacturers keep out of American markets, the same viscosity breakdown that explains why Japanese domestic Lexus engines at 300,000 miles look different inside than American Lexus engines at 150,000 miles. That video will change how you look at every oil change you've ever had. Don't miss it.